Greetings everyone, this is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. This time we're talking about the week of July 25th, 2022, so we're reaching late summer here. And as we get to late summer, one of the markers, one of the things we like to look at is Sagittarius. So we're going to talk about Sagittarius this week, and there's so much to talk. I'm sure we've talked about it a little bit before, but there's so much to look at. There's so much to think about with Sagittarius that it's very likely we may not get to everything that's scrawled on the board here, and we may bring this may be the first of two parts to talk about Sagittarius. So we'll do this in a later week. And just to make life more exciting and uncertain, the second week that we talk about Sagittarius, if we do break it into two parts, may or may not be next week. We may come back to it a week or two after that. So first, let's just find the constellation of Sagittarius. Sagittarius looks like a teapot, and the body of the teapot, all of these stars here are sort of second to third magnitude stars, meaning they're relatively easy to see, but they're not jump off the sky bright. So especially for those of us who live at mid-northern latitudes like I do, here I sit at 43 degrees north latitude, this skims the horizon. This main asterism of Sagittarius that is the teapot is low enough to the southern horizon that it's a little bit hard to see. It never gets very high in the sky. But we have four stars that make up the body of the teapot. Then there's a lid of a teapot, the spout of the teapot, and the handle back this direction. I think that spout's probably tipped out just a little bit more than what I drew right there. But that gives you a pretty good visual representation of what you're looking for. Now, right now, the best way to find it, always the best way to find it, is to start with bright orange Antares, which is over here, about the height of the top of the teapot, the dome of the teapot over here, is bright orange Antares in Scorpius. And Scorpius is a little bit brighter, especially Antares, and you've got the 3 or 4 stars that mark the head off to the west of Antares of Scorpius, a big sweep of a scorpion's tail. Depending on how far north you are, you may or may not be able to see that entire sweep of the tail. So Sagittarius sits above the scorpion's tail, above and behind the scorpion's tail. Right now, over this direction, over to the east, is Saturn. So when you look south, you go out right now. This is great. As it gets dark, 10 o'clock at night right now, Sagittarius is getting pretty high in the sky. It'll be good for the entire month of August and into September. And so this is well placed for observing right now and for the month or two ahead. And so you go out as it gets dark, good and dark, 10 o'clock at night for me that is right now. I'm looking south. I see the teapot asterism of Sagittarius glowing in to the south like that. And it's sort of framed, it's sort of centered between Saturn to the east and Antares to the west. Right when it first gets dark, Saturn may not be up yet over here to the east, but it's off that direction, and it's a little closer. It's sort of between those two bright points, and it's a little bit closer to Antares. So that's a way to go out and try to find this teapot asterism of Sagittarius if you haven't found it before. Once you start to find it, for me, this is one of these patterns. This is one of these asterisms that just pops off the sky. Once I've seen it, once I learned it, once I got it, it's not like I struggle to see it again. It's right there, and I can find it readily. So what we want to think about with Sagittarius is when we're looking at Sagittarius, go out this week, see if we can find these stars. When we're looking at Sagittarius, we're looking directly at the center of the galaxy. So the center of the galaxy lies right on the Sagittarius-Scorpius border. Remember, this is Sagittarius, and Scorpius is over here, and Capricornus is back here. That's where we're going to find Saturn right now. So Scorpius is over here with bright orange Antares up here. Now you're looking right directly at the center of the galaxy, 26,000 light years out there. And so the center of the galaxy, we live in a spiral galaxy, and so we're out here someplace, and we're looking right down the disk, right down the flattened plane of our galaxy to the center of the galaxy down here is Sagittarius. And when we look at this, we can say, okay, we're going to look at Sagittarius, look down this direction. We see the bright band of the disk of our Milky Way stretching up towards Cygnus, back up to the north, and just merging into a massive glow of stars and dust and gas and stuff down here in Sagittarius. Just a wonderful sight to look at down here in Sagittarius, looking this direction. So we orbit the center of the galaxy. So when you're looking down here right now, you're looking right at the center of the galaxy. We orbit about every 235 million years. So picture yourself on this merry-go-round with your back to the outer edge, facing the center right now as you're looking down here at Sagittarius. To find that center of the galaxy, as with, I think, all spiral galaxies, there's a supermassive black hole in the middle. And so we're orbiting around this massive black hole in the middle of the galaxy. And that black hole is right here with this X that I've marked. You don't see anything if you go look for it, but it's worth going to look for right now anyway, to say you find the spout of the teapot. Delta, gamma, and epsilon form the spout of the teapot, where it connects to the, delta and epsilon form the westward side of the body of the teapot. Move up about, so the distance from epsilon to gamma, move up that distance about halfway up, and a little less than half that distance out. That's the center of our galaxy right there. Boom. You're looking at the center of the Milky Way where we're orbiting. Beautiful. Spend a little bit of time poking around there. The nearest interesting objects to see are just to the south of here. There's a string of open star clusters along here that are relatively faint but attractive open star clusters to see along here. Every single one of those open star clusters is actually in the constellation of Scorpius. So the Scorpius-Sagittarius border runs right along here, and you see the center of the Milky Way sits just across the border into Sagittarius, where that black hole is. But if you want to find these, if you scan to the south and a little bit to the west, you'll find these open star clusters, and these are actually all in the constellation of Scorpius. Now, we figured out this. Harlow Shapley measured the distance 100 years ago, measured the distance to the center of the galaxy by measuring the average distance to the globular star cluster population. So globular star clusters live in a halo around the center of the galaxy. Open star clusters live in the plane of the galaxy, as do nebulae of all types. So star death nebulae, supernova remnants, planetary nebulae, where low mass stars have puffed off their outer layers, have blown off their outer layers. Star birth nebulae, just reflection, just gas clouds, reflection nebulae, glowing nebulae. So basically, all of this is there's just so much stuff going on in the disk of the galaxy. So when we look at this direction, it's why there's too much stuff on this board for us to probably talk about in 1 week. And so we can think about Shapley saying, Shapley looked at this, he wasn't the one. You look at this and you say, the globular star clusters, we see a couple hundred of them in associated with the Milky Way, and there's 88 constellations on the sky, but over half of those couple hundred globular star clusters actually exist in 3 constellations: Scorpius, Sagittarius, and Ophiuchus, that sits right up here. And so you'd say, okay, there's a predominant direction for the globular star clusters that we see, and so that must be the center of the galaxy. Again, Shapley wasn't the first one to say that, but he was the one to try to measure the distance, the average distance to those globular clusters, to tell us how far we were away from the center of the galaxy. He had a little bit of trouble with dust obscuration primarily. A lot of trouble with dust obscuration, which caused him to overestimate that distance and get a big galaxy, a much larger size to the galaxy than what we ended up with. But he did set the scale. He was really one of the first to say, okay, we're not at the center, and it's a big galaxy, and we're stretched out here, and we can do better at trying to measure this distance. And so that's what we did here. And so we can start this week to say, okay, let's back up a step and say, when we're looking at down toward Sagittarius at the center of the galaxy, we're looking into history. It's just a beautiful history. We're looking at a supermassive black hole. We don't see anything there, but we're looking at this region that is the center of our galaxy. And we're also looking at just anything you want to see in the night sky, except for external galaxies. There's so much of our galaxy in the way, we can't see through our galaxy to see external galaxies like the Milky Way. But there's so much stuff along the disk of the Milky Way, we can see just about anything we want. Open star clusters and nebulae up here, globular star clusters down here. There's open star clusters down here and globular star clusters up here. I just picked some nice bright ones for us to look at. So let's start with the globular star clusters. Let's remember this story of Shapley measuring the distance of the center of the galaxy using globular star clusters. Goodness. So globular star clusters, remember, are these star clusters that contain maybe 500,000 stars. They may not contain quite that many, some of them. and so some of them might get a little bit more, and they're dense. You know, when you look at them in your telescope or with a pair of binoculars, if they're big and bright enough, you see a fuzzy patch. You don't see much in the way of individual stars. So two of them lie right along the base of the asterism of the teapot, M70 and M54. M70 is probably the easiest of these to spot because it's about a third of the way from epsilon to zeta, which forms the base of the teapot. So you just take your small telescope and you just start scanning across this direction, and bam, you'll run into M70. Not a spectacular globular cluster, but a good globular cluster. M54 is much closer to zeta and just up off that line ever so slightly, but poking around in there, you can probably find M54 as well. Now, M22, to my eye, M22 is the best of these. And M22, I find phi is this upper left part of the body of the teapot. I go up to lambda, which marks the top of the lid, and it makes a right triangle, and about half the distance from phi to lambda up this direction is M22. So there's your right triangle like that, and M22 is in there. It's well worth trying to find M22 that way, and look at that globular star cluster. Just a beautiful globular star cluster. Globular star clusters consist of all old stars. These clusters were formed about the same time the Milky Way was formed, so they're very old stars. They hover around the center of the galaxy. We see three really fine examples here in M70, M54, and M22 in Sagittarius. Now, we've got wonderful nebulae, and we've got wonderful open star clusters that live in the disk of the galaxy as well, and we'll talk more about those. Maybe next week, maybe in a couple of weeks, we're going to come back and talk more about Sagittarius. For this week, get out there, find the pattern of Sagittarius. No, we're going to return to it. We'll think about Scorpius, think about Saturn over here, and then see if you can find a few of these globular star clusters. And enjoy the week, everybody. Hope you have clear skies and you have a great week, and we'll have something more for you next week. As always, thanks for watching.